is Josephine, and I'm here with Ivy, Abigail, and Carol. Today we are here at BXC Aquarium, and we're going to explore the diversity of marine life. Let's dive right in! Wait, but does any of you guys know how these marine creatures are able to survive and thrive in their environments?
Oh, right. It's called adaptation. Adaptation is how living organisms change to adjust to their environment over time to increase their chance of survival. There are many different types of adaptations, including aquarial and terrestrial ones. There are also psychological adaptation, anatomical adaptation, and also behavioral patterns.
That's right, Ivy. Animals evolve these adaptations over generations, helping them cope with challenges like food scarcity, predators, and environmental change. This is a beautiful process.
As we explore the aquarium today, pay attention how the adaptations play out a different role in different species, from the way they move to the specialized features that they possess. This adaptation is crucial for their survival in nature. Great insights, guys! Now let's dig deeper and explore some specific examples. Carol, do you have any favorites you'd like to share?
Josephine, do you spot the stick insect here?
No. Which one is it?
That one.
What? It looks like a branch.
This species
Acanthocilla inermis
has an anatomical features, and let's check it out.
Acanthocilla inermis, also known as the unarmed stick insect, exhibit anatomical adaptations that contribute to its survival. This species has a long, thin body and 3 pairs of thin, jointed limbs resembling twigs, which provide excellent camouflage, making it hard to distinguish from real sticks. The body color and texture vary, with many shades of green, brown, or yellow, further enhancing its camouflage. Additionally, Acanthocilla inermis, like other stick insects, perform swaying motions to mimic the movement of a branch in the breeze, further aiding in its camouflage. These anatomical adaptations help the Acanthocilla inermis to hide in plain sight, making it well suited to its habitat.
Moving on to the underwater world again, let me introduce to you the black-tipped shark, or the Carcharodontis melanopterus. It has many anatomical features that helps it thrive in coastal waters. Anatomically, black-tipped reef shark, or the Carcharodontis melanopterus, have a sleek, streamlined body with a gray upper body and a light underside, along with a tail built for speed. Other than that, this black-tipped reef shark also has long, thin serrated teeth that are located in rows and are well suited for the diet of reef fish. Aside from anatomical, Carcharodontis melanopterus also exhibits several physiological adaptations, including cardiorespiratory efficiency and also stress response. First of all, black-tipped reef sharks are well adapted to tolerate anoxia, which is a condition of a low oxygen availability. They have good cardiorespiratory system that allows them to maintain oxygen uptake and metabolic rates even under low oxygen conditions. For stress response, just like other sharks, black-tipped reef sharks have secondary stress response that includes changes in blood pH, oxygen uptake, and metabolic rates. These changes can be influenced by factors such as temperature and duration of capture.
Wow, those examples are truly fascinating. I think I'd like to explore an animal adaptation myself. There's an otter! Oh my god, otters! The onyx cineris, commonly known as the asian-small-clawed-otter, is an otter species native to South and Southeast Asia.
The asian-small-clawed-otter is a carnivore that lives in small streams, rivers, marshes, rice paddies, seacoasts, and in mangroves. Its streamlined body helps it dive in water for fish. Not only do they feed on fish, they also feed on a range of other aquatic animals as well as land-based animals. The onyx cineris is a social species, as they live in family groups of up to 15 to 20 individuals, although they hunt by themselves. Rather than using their mouth, asian-small-clawed otters use their 4 paws to locate and capture food items. Their sensitive digital pads enable them to feel under rocks or in murky water for food. They dig in sand and mud at the shoreline for various types of shellfish like clams and mussels, and crabs. These otters do not like open areas as they choose to inhabit areas with low to moderate tree cover instead. They spend the majority of their lives on land, where they dig a burrow in the side of a river called a holt. These otters are a very vocal species and have a vocabulary of at least 12 different vocalizations used for contact, summons, greeting, threat, and alarm calls, which can occur visually, chemically, or through tactile cues, such as social grooming, hormonal changes, and posturing. They also use scent markings called spraying as a form of communication, emitting an intensely musky smell on their feces that can delineate territory and communicate information concerning identity, sex, sexual receptivity, and time elapsed between scenting visits.
Now let's shift our focus to another marine adaptations. Catocylus mosaicus, or known as the jelly-blubber, with their unique physiological adaptations. Now let's check this out.
Jelly-blubbers have a mushroom-shaped bell that can reach 30 centimeters, usually found in harbors or estuaries. Their color ranges from bright blue to creamy white, or even brownish yellow. They have 8 textured oral arms that hang underneath the bell. Blubber jellyfish showcases both behavioral and morphological adaptations that contribute to its swimming performance and foraging behavior. A study on the swimming performance of Catocylus mosaicus revealed that it has a body morphology quite unlike that of the other swimming medusae, which affect the mechanism by which thrust is produced. The jellyfish is propelled during both bell contraction and relaxation by different thrust-generating mechanisms, including the expulsion of a jet fluid from the subumbellar cavity, resulting from the interaction between the counter-rotating stopping and starting, creating a vortex superstructure and propulsion. The species is also able to utilize passive energy recapture, and it has a relatively high pulsing frequency, which affects the formation of vortex structures and their interactions during swimming, potentially providing a benefit in swim performance during locomotion. These adaptations contribute to the jellyfish ability to move efficiently in its habitat, allowing it to thrive despite the dynamic environmental conditions in coastal lagoons and estuaries.
Well, that wraps up our amazing journey today. Thank you for watching. Until next time, bye-bye!